All right. They're gonna close. I guess it's showtime. All right. Hey, start countdown. Hi everyone. First of all, thank you all for showing up. My name is Darren Hubert. I'm an architect with Microsoft Services. Really appreciate you all coming to this session, Architecting the Internet of Things. I have been informed and I realize that I am the last person, or I'll be the one holding you up between alcohol and or a flight home to see your families and stuff like that. So I will do my best to hopefully let you out earlier than not, because one of my colleagues, a guy named Stephen Cohen, gave a session. I hope you all were there. There was many people. It was brilliant. On hardcore architecture, and his advice was let everybody out early, especially it was right before lunch, so because there's a distinct competitive advantage to getting out, as I trust everyone just saw with that long line for lunch. I assume it's going to be the same with the alcohol, so I'll make a concerted effort to get you out as soon as possible. Here, let's go into this, and I just want to have this sort of set the stage and set the tone for this presentation. And it's all about architecting, emphasis on architecting IoT solutions and the Internet of Things. So I'll just read it. You know, collecting information from lots of devices, way cool. If those who are doing it in the audience, if you guys are doing that in your companies or with your customers, thumbs up. That is, by definitions, telemetry, just telematics. Good stuff, but that's not IoT. Merging perspectives between devices, systems, and humans. Ultimately, there's the consumers of all this. To build a better understanding of our world, it could be lighting in a building, AC, ambient intelligence, and the like. That's great, but tying these two things together, insight into action, therein lies the promise of IoT. I want to have that sort of sit as the basis, foundation for this presentation. My objectives today are to help articulate these points, understand what IoT means for architects. I hope everyone here, and I trust I'm going to treat you all as experienced architects that are delivering software solutions for customers. To learn the technologies, because these technologies are advancing very, very, very quickly. New stuff is coming out constantly. Very important to learn the technologies, and if you haven't known them yet, how to learn how to begin applying them to deliver what I will call a modern solution. And we'll get into that. And then be better able to talk about IoT to customers. And I think that's important. So the session overview, I'm trying to break it up into these groups. What is IoT? Why is it important? I'm sure some of you will have seen a lot of the data. I'm just going to re-emphasize it to, again, set the groundwork for the discussion. IoT from an architect's perspective. Technologies I feel we need to know. There's a lot of them. These can be really big, complex, hairy projects. They're not necessarily easy. And there's a lot of technologies out there, and I'm just going to try and introduce ones which I feel are important to know. Common patterns and practices. And we've, in Microsoft, we finally get good projects out there, and we're building up a body of evidence, a body of knowledge to start documenting what are these practices, what are these patterns. I look forward to sharing those with you. And then if we have time, I'll get through what we feel are some real world examples to help illustrate what's the art of the possible. Some stuff you may be aware of, may be top of mind, some stuff maybe not. We'll see. Expectations. It's a level 200 architecture session. I do not have an Arduino. I do not have a Raspberry Pi. I do not have a NetDuino. I'm not going to open up Azure. I'm not going to stick a match underneath a sensor and have it blink a light. So no blinky demos. I'm not terribly amused with them personally. I've seen enough of them to, okay, whatever. I don't see the value in that. So no code, no flashy demos. So it's an architecture session. IoT, the Internet of Things. What Gartner says is it's the physical network of objects with embedded technology to communicate and interact their internal states with external environment. That's a definition by Gartner. I think it's certainly true, but I believe it's much, much, much more than that, especially if we're going to move forward with the following. Gartner predicts that there are going to be 25 billion devices by 2020. That's an enormous amount. And it's not just smartphones, it's not just PCs, it's not just tablets. It's a plethora of sensors around buildings, around infrastructure, around being able to manufacture new goods. All of those things, as I trust everyone knows, that's what's going to make up this, this number. So what is it? What is the Internet of Things? For this discussion, it's unique objects connected to the Internet, devices, not people, bidirectional communication, and new types of insight. One story that I think is really unique here is when I say devices, not people. There is a solution that Microsoft and our partner Fujitsu developed in Japan to help with the beef production, the cattle beef production. So they've actually connected cows to the internet. Some people may know this, some people may be surprised to hear the story. But through machine learning and through veterinary analysis and understanding farmers who have herds and they want to optimize the growth, the output of beef of their cattle, they learned that the typical, after a cow delivers, the typical period before they can re-inseminate that animal was always believed to be about 6 months. And they figured out over time what were the triggers to say maybe it's shorter or not. And they learned through veterinary analysis and machine learning that it wasn't necessarily 6 months. It could be as short as 3 months, but it was determined by the cow's body and moreover, how many steps a cow took. It turns out when a cow is in heat, it kind of runs around a lot looking maybe for mates. And they would if you put a sensor and you could put on a pedometer on a cow and you found out roughly how many steps it was taking, you could really time pretty well and very accurately when you would need to re-inseminate that cow. Pretty interesting. And with machine learning, they took that even a step further and could determine whether or not if there's a 48-hour window, maybe I need to do it, if I want to do it ahead in advance, I have a higher probability of getting a bull, of getting a male cow if you want to be a beef producer. If I do it, maybe 24 hours after the main window, then maybe I can generate a cow. And there's a 70% chance, and statistics are statistics, it's math, it's fact, that they can have a higher percentage, a higher probability of having a calf versus a bull. So they're taking this one step further, and the result of this, which is why it's a published case study, is that the farmer, the herd owner, has increased his output by 31%. And in the beef industry, that is an enormous, enormous return on investment. Again, pretty neat story talking about what is the Internet of Things. So when I say devices, not people, uniquely cows, yeah, it's out there. Economically, why is this important? These are numbers that are above my ability to comprehend. But 7.2 trillion by 2020 by IDC, that's what they say. And then there's a certain number of economic value add, and that's supposed to be a little less than $2 trillion across multiple sectors. The leading industries that are out there right now are utilities, insurance, ag, as I just mentioned, factory, automobiles. There are a lot of scenarios about connected cars, GM with their OnStar system. I don't know if that's made its way here to New Zealand, but that's certainly an IoT play. Transportation, and of course there's a lot of consumer plays out there as well. What we're seeing is that, and analysts as well, is that in most industrialized countries, a lot of the opportunities that are out there are really more brownfield than greenfield. And more of the greenfield opportunities are going to be largely from developing countries. So they're going to have less infrastructure, less assets already that are tagged with sensors and generating type of data. So it's easier to industrialize those types of countries, and those will be more greenfield types of opportunities where, with the asset turnover that you have in industrialized countries, it may be a little slow on the uptick for IoT solutions. Interesting point to note. So I would argue that more of the opportunities in industrialized countries perhaps may be unique business models, greenfield opportunities, if you have to go look for them. They may not be prevalent, but I believe that they're out there. Another thing to show, and this is an old Microsoft slide. And this is what our story was back in 2010. These were this is the scenarios that we thought were made up IoT, okay? From the home to the workplace, you had a connected refrigerator telling you maybe when you needed more milk. I'm sure everyone's heard that story. Connected automobile, GM's been doing this for a long, long time. All the way through HVACs for green optimization and energy savings, all the way through, security cameras, and of course television. So I have a smart TV now connected to the internet, all that stuff, good. Today though, it's becoming much more prevalent. These are all things that we're seeing, everything from health, pet tracking, and bicycle riding statistics. There are all these new Fitbits, all these new types of solutions that are out there, and it's all within the umbrella of IoT. Okay, so it's just a swath of things that are going on out there. I would argue this is still the tip of the iceberg. There are numerous scenarios, numerous capabilities that are out there that have yet to be thought of. They're just not, we just don't know. And I think it's, for me, my point of view is that it's a symbiotic relationship between the technology and the capability of the technology and the requirements that are coming out there from industry or from consumer world to identify which, they're going to feed off each other to create new scenarios which will create need for new technologies like machine learning, streaming analytics, that type of stuff, which will then create more scenarios, and it'll go and go and go. So I think we're just, as a community of architects, this world is ever expanding, I believe. It's also feeding into what's called the Gartner Hype Life Cycle. And everyone, I hope, has seen these Gartner Hype Life Cycles. And it starts off with a technology trigger, peak of inflated expectations. That's where it's at the peak of hype. And then reality sets in that it's not going to solve every business problem that's out there. And then all of a sudden, people start to feel a little let down, if you will. And then it goes into that disillusionment trough. And then up that slope of enlightenment, because people start learning, people start understanding what failed previously. And let's not repeat that. Let's see what worked. And then all of a sudden you start getting more wins, more maturity, more adoption. And then I think that's where it sort of plateaus and becomes commonplace. That's really their life cycle, and they have a ton of data across industries, across technologies to come up with this. Literally, right there, that's where we are with IoT. Literally, that's where we are. And kid you not, we're at the top of it. So interesting that there was a lot of people here, and I think that attributes to the fact that there's a lot of hype around it. Okay, an architect's perspective. IoT, our point of view is that IoT is at an inflection point right now. And I don't know if it's going to go down that trough of disillusionment. I feel that that's up to all of us as a community to help figure this out. Maybe we continue on an accelerated curve. We'll see. Maybe achieve those large numbers that Gartner was publishing. Hardware is getting cheap, certainly. Machine-to-machine solutions are becoming more and more mainstream. Machines are really starting to talk, communicate, have conversations with each other, be able to inquire, command, have some actions. That's becoming more ubiquitous. Connectivity is proliferating with Wi-Fi, with a lot of Bluetooth technology. There's a lot more connectivity that's out there, and that is growing and growing and growing. I gave a talk 2 days back on design thinking, and one of my use case for that conversation was on a solution in UK for guide dogs, where we're helping blind people be able to navigate around cities and make their lives more mobile and have better experiences, give them more freedom. And all that is through the proliferation of connectivity. Software is getting much more advanced. And this is going at an incredible, incredible pace. The people who are the experts in Microsoft, the people who are part of the Azure teams, the product groups, the CAT groups, customer advisory teams, they are adamant about arguing that if you took an Azure certification a year ago, 6 months ago, whatever you know then or whatever you were tested on and you proved that you knew then, you don't know anymore. There's so much more that's happening, that there's such a short shelf life in the technology, and they are going so fast. And it's not just Microsoft. Others are doing it as well. The technology is advancing so fast. And unless you're doing it, unless you're in the thick of it, it's really hard to keep up. So it's going to take a team of peers. You're going to have to work with a network to identify and create a IoT solution and learn from it and grow and make sure that one that's quote unquote supportable, scalable, and the like. And another inflection point is that the cloud is out there. Obviously private, but I'm referring to public cloud for cost, scale, and flexibility, all super, super important points of an IoT solution. That said, general technical requirements for IoT, huge number of devices that are out there. Again, I referred to 26 billion, but when you start doing these solutions, you may start with a small POC, and it may have 100 devices, maybe it's well more than that, depends on the scenario. But as you start learning and as you start developing and having that win, being able to bring it back to the business and they see the return on the investment or the opportunity that it provides, those devices will multiply and multiply and multiply, and it will go like a hockey stick. Okay? A lot of devices. Hence, you'll have large scale requirements. So being able to, if you have a on-premise system with maybe you're keeping everything on a SQL server and that was the initial cost of the POC, you wanted to do that, you had extra capacity in your data center, if you start having that success, ultimately that thing might just tip over and you're going to have to expand it out again. That might just tip over. So be cautious about that. I would say that there are vague security requirements as well. Not a lot of people have gotten fully versed into threat modeling, and that's probably the first step that as architects we need to master in order to understand the array of threats that govern security. So again, that's something that architects need to know. This stuff, once you turn it on, once you plug it in, these devices just generate and generate and generate data, and all of a sudden your storage is just going to grow, 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 grow. And it's perpetual over time. More devices you get, more data you acquire, and you're going to have to be able to adjust and architect solutions for that volume of data. Maybe you start off with SQL Server for it. That might not be the right architectural decision. And end-to-end integration, again, importance. I want to talk really quickly on just some patterns for messaging. And this is important for IoT. It really boils down to these four things. First thing, telemetry, where the device is just pumping data and you're able to consume it. And that's all that is. That's just telemetry. The second is, I would argue, is an inquiry, where it's saying, I'm okay, I'm okay, I'm okay. Do I need anything? I'm okay. It's making an inquiry. A command would be where the message is being driven by a cloud service as opposed to the device itself. It's saying, okay, we've gotten data. Maybe we've detected a leak, and maybe you're a valve that governs gas, if you will. And now you need to shut down, and not just you, maybe other points as well need to shut down, so you're passing a message and may need to go to multiple devices. That would be a command. And then lastly is just notifications. And notifications are, we'll talk a little bit about push notifications in this session. But that's just sending the notification that here's a message, do with it what you will. Here's the message, do with it what you will. Okay? So how do we solve these basic patterns? For all architects, you're all very familiar with SOA, and this is all service-oriented stuff. But if we go with service-oriented stuff, I would argue that that's something that may introduce problems later on. So obviously, as a SOA architect, you're familiar with having an endpoint, still holds true, passing your messages back and forth. You're going to have to secure that, typically with a TPS chip and SSL, what we do. Once that message gets in, we're going to have to parse the data. It's going to have to go to another system for analysis, maybe another system for reporting, so a pub-sub model. And then the thing that makes that happen, obviously, is the routing of the command. Simple stuff, but I don't know that that's the right architecture going forward. So the challenge is when you have this volume of stuff, addressing that many devices is a huge challenge. And if you have a lot of devices and they all have their own IP address, that can, by definition, then they're servers, and then they're open up to the internet. And if they're servers and they're published, then you really have potential security requirements, the security issues. Again, the scale issue that we spoke about a moment ago. Connectivity, especially in IoT. If you have, there are solutions. One of my peers was working with Scania, which is a truck manufacturer out of Sweden, and they're trying to help optimize their fleet. So they're putting these sensors and they're putting everything on these trucks, and they go in and out of service. They go in tunnels. They lose connectivity, and you can't have that level of trust. You need it, but it's not always going to be pervasive. And again, data volume, creating that the enormous amount of data as you scale, as you grow. And then, of course, the device size. There's not so much that you can put on a lot of these devices. A lot of these devices are already out there in the marketplace, and they already have certain limitations. Maybe they are the original manufacturer, when they put the sensors out there, didn't engineer for scenarios that are now being afforded the opportunity to be out there due to the new advancements in software and the technology. So, something to worry about. But how do we do it? So as we go through, we've learned a few things. We've learned some basic principles. This is the first principles that we've learned for these solutions. So address addressing, a pub-sub model. Or I would argue you have a gateway, an internet gateway, that's what you connect to, and the devices then know, I'm not connecting to the internet, I'm just connecting to this one thing. So it's a pub-sub model. The messaging would go to that gateway. The gateway would then go to any devices that are registered to it. From a scale perspective, the cloud. Certainly on-premise folks may want to keep this data on-house, or certain businesses choose to have this data on-house. So there are certainly on-premise cloud technologies that are out there. Connectivity. The best way to address that is through queuing. And through queuing, there are certain new protocols out there that are being now more pronounced for IoT solutions. Well, I'll talk a little bit about that in a second. Data volume, cloud storage. There's a lot. Storage is getting really, really, really cheap. And you can store petabytes now. I'll talk a bit about some of the technologies that are out there that allow this scenario to happen. And the device size, here I go with the types of messages. You can get really, really small messages now. You're not passing SOAP in an IoT solution. That actually becomes expensive. If you're passing SOAP in an IoT solution, obviously a cloud provider like Microsoft and Azure, we charge on compute. So if everything that goes in, all of that ingestion, if it's a big message, well, certainly that's more cost to the customer. So we have to really work with a lot of the new protocols that are out there. MQ telemetry protocol, and you have advanced message queuing protocol, AMQP. So those are the new ones that are out there, part of architecture. So as a reference architecture for those architects who are out there, these are the things that you need, that we see as being important for solutions. So everything from devices and data sources, that's the thing that's generating all of the data. More often than not, it's going to be bidirectional. It's not just going to be telemetry data going in one direction. There will be a gateway. Not always. Some of these devices have that capability. But we see that there's a lot of gateway. And then you'll have, of course, your ingestion, event processing, analytics of sorts, storage, and clearly data visualization and presentation. Okay, so what do architects need to know? This is just my point of view. I trust everyone else has a different point of view, and that's cool, all good. But these are some of the things that I feel as architects we need to at least have a working and a pretty deep knowledge of in order to deliver IoT solutions. Okay, I'm going to start off with, here are Microsoft Azure IoT services. And these are all of the services that are publicly available for you to pick and choose depending on your business requirements to architect the optimal solution given the business scenario with which you're presented. There's a lot of them out there. Obviously, you have the data producers through transport, storage, analysis, and obviously presentation. I'm going to focus on these ones. I think they're the ones that I think are the most exciting. They're the ones that I feel are going to be most appropriate for a majority of IoT solutions. And I'll try and get into that really quickly if I can. Okay. So as far as an architect, how much depth do you need to have in all of this stuff? Show of hands, does anyone here, and I believe the answer is probably yes, have an idea of what all of these screens are? Awesome. So what this is, on the left here, this is an algorithm for machine learning. People need to know, in order to generate a predictive analytical solution, how you go about the whole experimentation process. And this is really kind of the stuff that data scientists need to know. So as an architect, you have to really know how that model works. How does one go about creating a predictive analytical solution? On the right here, this is just AMQP. That's the protocol. That's sort of how it works. And then the one on the bottom right, this is windowing that happens with streaming analytics. And there's multiple types of the concept of windowing. And this is really important for if you need to if you need to stream your data and capture it in real time. What are the segments? How do I need to go about monitoring that? Because again, that's a whole configurative and customization aspect. You need to understand whether or not it's sequential or on top of each other. There's a whole discipline here, and I just think it's something to know about. I don't know that architects need to have depth in. Okay? So as far as these things, again, the 7 things that I think are important. Event Hubs is part of Azure. This is the telemetry ingestion service. It is built on top of, if you will, it's an iteration of Service Bus. And it's scalable to the pub-sub model. So this is the service that will do it. And it's your telemetry ingester. And if you're thinking of sending, for example, like 20 meg files through Event Hub, wrong architecture, that's going to fail. It's really micro messages, so 1K per message, but you can take in about the statistics, because this ultimately came, one of the reasons for this uniquely came from the Xbox team. And a lot of their gaming requirements needed, because obviously Xbox runs on Azure. And a lot of the games, all of these online multiplayer, I'm not a gamer, but all these online multiplayer games, they need to be able to take in this many messages to make the whole thing work. So that was the challenge. That was the business problem. And the Azure team developed Event Hubs to help manage that. And it turns out it's a great ingestion tool for IoT solutions as well. Okay? Next thing, DocumentDB. SQL, as I mentioned earlier, may not be the right solution. It's certainly a good solution. It's a great technology. We all, as architects, know and love it. But having a fully managed NoSQL document database service is really an amazing thing. Schema-free, so it can take data from multiple sources, multiple devices, and you don't have to worry about managing the schema. Because once you start having to do that, things start to fail. Things start to fall. Things stop. And that's one of the more important things, is to make sure that you have a solution that can go with requirements, go with scale. And it has CRUD access for querying. It does the JavaScript processing, and it integrates with big data solutions. DocumentDB. Okay. Azure HD Insight, just to prove that Microsoft is very friendly. We love to play with open source against maybe a pivot. If you've been coming to TechEd or Ignite for many years, and you've heard Microsoft message, open source isn't one of those conversations we've been having in recent years. But it is today. This is who we are. This is where we're going. We're full stop behind open source. Linux, certainly. A lot of, by the way, most devices run on Linux in the IoT space. Okay? So it scales from terabytes to petabytes on demand. Again, just huge amounts of data that it can do. Again, in a cheap way. It's deployable on Linux or Windows. And more importantly, for those who have Hadoop clusters on premise and you want to leverage it in the cloud, you want to scale out that way, it will run Storm, it will run Spark. Storm is for real-time events, and Spark is for in-memory data analysis. Those two solutions, the part of the Apache Hadoop platform, are also capable with Azure HD Insight. Okay? Great technology. Again, I feel it's very important for architecting solutions for IoT. Okay? Stream analytics. This is a really important technology. One of the things, I just want to tell a quick story. I was the chief architect for a Microsoft solution for a global drug manufacturer. And their problem is that they had all of these, well, first of all, in the drug manufacturing industry, you are heavily governed by protocol, standard operating procedures, the Food and Drug Administration, and you have to go through all sorts of things to be compliant. And one of the things that the FDA really hits hard on drug manufacturers is they want them to be compliant, and they want to make sure that there's no side effects or adverse events to any of the drugs that they issue and are part of the general public that they consume. So one of the things that my customer chose to do is to create a solution that would look at a variety of channels to help detect what's called signal detection. And they needed to know, for example, if someone was taking one of their drugs and would either tweet it out there or would call a call center. I mean, there's multiple channels. The channels were limitless. And would say, hey, I'm taking this drug, but maybe I've got high blood pressure and I had an adverse event. Those are the things that they need to monitor. Or maybe someone's taking one of their drugs and they had a fatality of sorts. It may not have been caused by the drug, but they don't know. It could have been because they smoked and they were having lung issues, or maybe they had cancer and it was the cancer that won. Maybe the drug was helping stop the cancer, but the cancer ultimately, they succumbed to it. So they have to manage all this stuff because ultimately it helps with being compliant to the FDA and saving lives. So the solution leveraged streaming analytics in order to monitor these events, to identify and see if they could come up with a correlation between these events and these drugs, and maybe these drugs and these bodily functions, high blood pressure. And that all goes into their research. And that way they have to do more research to make sure that they're serving and they're delivering a very safe product. So again, this was for adverse event correlation and product complaint compliance and correlation. So really interesting story around streaming analytics. Very popular topic, and especially I believe so with IoT. And then of course you can't have that without machine learning. And this is super important, and it's not the first, Microsoft has Azure ML. We're not the only provider of machine learning engines. Some of them are on-premise, some of them are in the cloud, but really important for stuff like preventive maintenance. One of my customers, they're a hospital authority, and one of their big issues is patient readmission. I didn't know patient readmission was such a big process and such a laborious process, and actually quite expensive. So if they're able to predict with a high degree of certainty which patients are more apt to be readmitted, that's very important to them, and it's important to the authorities that manage that. So something to learn, okay? Machine learning. And the second to last one is notification hubs, scalable mobile push notification engine. And this targets millions and millions of notifications and sending. I think a couple examples of what this would be send location-based coupons per user segments. If you're a Starbucks and you're near and they detect that you're near, they can push a coupon to you to say, come get a free cup of coffee. That's one scenario. Another scenario is I live in Singapore, and in Singapore, cars are extremely expensive. I mean, I wouldn't want to, in US dollars, a car, if I want to buy like a Volkswagen Golf, it might be 110,000 US dollars. It's that expensive with all the taxes. So not really something that I can do. So taxi services are out there, and they're actually cheap and they're really darn efficient. And you're able to interact with them with your cell phone, and they will locate the closest car, the closest taxi, and then be able to text you immediately, yes, you'll have a ride in 3 to 5 minutes, and by the way, here's the license tag on the driver, and so the driver knows it's you, and they'll come over and you can monitor that, and that's all done through a notification hub. Really cool technology. And then for users, business users, at the end of the day, IoT is all about business users and providing value to business users. And our tool for that, I would argue, is Power BI. Does a great job of putting all of that data in simple to use visualizations, visual to use graphics, so you can dig into it. Very helpful. It's more often part of Office 365, but certainly something to help track data in real time, especially with support for streaming data, Power BI. Those, to me, are some of the core technologies that architects need to know to deliver to modern business solutions. Okay? Talk really quick about some patterns. On the left here, we have devices, and most devices these days largely run Linux. Some run Windows, but more often than not, they're all running Linux. They will either connect, they have the ability to connect themselves to a cloud gateway, in this case, Event Hub. That's something, that's our, again, our telemetry ingestion service. You'll have to know that if you're going to connect anything, Event Hub is the thing to do it to. Something very important to know. Or the devices may need to talk to their own field gateway, and they'll have to have protocol adaptation, because Event Hub's really only is the main protocol to ingest is HTTP and AMQP. So those are the protocols that we're most friendly with. So some of these may be old sensors, old devices, and they may not talk in that protocol. So you have a field gateway that does the conversion and helps advance that protocol. And these are really some of the basic overlays and patterns for device connectivity and management. But that's not it. There are other requirements that you need to have to know to be a modern architect here. Command and control, device identity, and device registry. That's really important. If you've got thousands of devices out there, you need to know which ones are specifically yours. You need to manage them as a person, no, not as a person, but as a unit, as a thing. So you have to manage their identity. You have to register that identity to know which device it is and all of the metadata about that device. And that's all around device management. So those are, I'm not going into the requirements there, but it's certainly very, very, very important. Devices, if devices are messed up, it's actually, I believe, and I would argue it's more expensive if you're an architect and something goes wrong with the devices. Maybe you misplace a sensor you put it in the wrong pins. That is potentially hundreds of, tens of thousands of dollars of delay and, weeks upon weeks of time. If you just are not accurate or not complete with your service, all you do is have to retest, recode, republish, and the cost could be, as minimal as being down in a day, kind of thing. So devices are certainly important, but not the focal point of this conversation. But that brings me to IoT Hub, which was announced recently as being part of Azure IoT Suite. And this is we're advancing our technology. It's not out there today. It's not part of the Azure IoT services, which was the first slide I spoke about. But IoT Hub, and it's coming with the capabilities. It's got bidirectional communication, device to cloud, cloud to device. Up to 10 million devices can be effectively within one tenant, if you will. So it's, again, it's telemetry ingestion. So it's based on Event Hub, does the device management, registry, and identity. And there's going to be a lot more that goes on with that. And that's IoT Hub, something to be mindful about, excuse me. And then once you get that data, what do you do with it? How do you move it around? So we have batch analytics, we have a cold path analytics, and hot path analytics. And both are different. You're going to use those differently for different requirements, different needs. So in the cold path analytics, you have things like HD Insight, Document DB, and Azure ML. Those are the solutions you use for that. And for your hot path analytics, certainly streaming analytics and Storm if you're using Hadoop or HD Insight. Okay? And then we have a fabric layer and an actor framework that helps apply business logic for that hot path in the event that you need to take action. Okay? And then, of course, you have the presentation aspects of it. So that's your Power BI for your dashboards. It's the devices. It's the smartphones. It's where the business users can see and can get data. In this example, I chose to put Dynamics CRM, if you will, in there, because that's something that can take in IoT data. If it's predictive maintenance, if you will, maybe I need to execute a service call on that. So it's part of that. I just want to help think a little more broadly. Okay? and that's where the notifications come in. Then we have push notifications with Notifications Hub, as we just discussed. All right, so here's my story. If you want to architect and understand how these things might be applied, again, everything, there's no one right answer to any of this. It's what's the right technology at the moment that you have to choose, and how do you want to best apply it. So for a predictive maintenance type of scenario, here is a architecture or a pattern you may want to choose. Coming through, we would do cold path analytics. We do Service Fabric in order to apply some learnings, apply some, if you will, some business logic to that data. And then, of course, maybe present it in front of Cortana Analytics or a web phone or a cell phone, rather, or other. I think Cortana is probably a really good way of managing this. This is for predictive maintenance. And if you're doing service delivery management, this might be another pattern where you're using cold path and hot path. And the case is, if it's hot path and this is something that we're monitoring and I need to send a technician out there and it's pretty urgent, then I may choose to have it run through maybe a CRM type of system, and the CRM system, once it gets that inbound call, can create a case, can identify the appropriate technician based on skills routing or other, and be able to help then manage that situation. Again, choosing the right technologies to solve the right business problems. As architects, just to be aware of how this all kind of comes together. I threw this out because I think it was important, just to show you again an example architecture for everyone here. Here we have something that's real-time telemetry, and it is coming through Event Hub. That's what that's our ingestion service. We would process the data in real time. We would use Stream Analytics, again, depending on the business scenarios. Run the data over to Power BI, but in certain cases, depending on the data type, we may push it to SQL on-premise, because offsite we have another SQL server, and that would then go through to Azure. We might leverage the machine learning model for any type of predictive analytics, predictive maintenance. This is just a type of architecture. Again, stuff on the north is happening in real time. Stuff down below is batch, and again, that's something around which to architect a solution. Certainly a viable solution. Here's another one. In this case, there's no telemetry going out. It's we're having an Azure Web Job that's running around, and we're going to, instead of a push model, it's a pull model. We're polling every 5 minutes. That might be a good timestamp in order to get the data that we need from, in this example, a public source of data, and then push that in through, again, our ingestion service, and then have that run through streaming analytics, again, in the hot path, and then while also pushing data into the cold path, just to show you how you have to be thinking in order to create these modern solutions. Okay? So risks of IoT. I tried, as I came into putting this together, I wanted to know that IoT actually is really, really challenging. It takes a village. It takes a lot of people to build an IoT solution. I would argue that the hero culture, which I come from, of individuals going on site, working with customers, and making the solution fix it, make it work right, make it more, make the SQL Server stand up again, that type of thinking is going to be dangerous, because it's not modern practices. It's not something that's scalable. It's not leveraging the cloud. It's not. Those are, if you're not new on the technologies, I believe that you'll run into trouble. I would also like to make the point, as architects, we have to really understand the business context. Understanding the business model is critical to these solutions, and it's critical to us being successful with these solutions. So the more we're able to bridge the actual business problem, because then you can decipher what actual data do I need to collect, and is that data being generated from the devices that are out there? If so, great, then we can play with it. But if not, then we have to set expectations accordingly. So understanding the business model, certainly super important, I would argue. Beware of the new patterns. They change constantly. Again, to the point earlier, is if you were certified on Azure sometime a year ago, the technology is advancing so quickly. Just be mindful, okay? Don't focus on the device. As architects, you have to know what's out there. Understand what type of data you're getting what's the type of protocol that is offering that data. But don't focus on the device, focus on the solution. Devices are cool, Raspberry Pis are cool, but focus on the solution. And unfortunately, and I'm a victim of this, sometimes it's easy to drown in a lot of this information. It comes at you so fast. And it's easy to work with your peers, work with the business, and you sort of get into analysis paralysis. Is this the right technology? Is this, do I need to stream this data? Do I need to go in a cold path for it? Do I use DocumentDB? Is that the right solution for it, or can I go with SQL, or do I actually need to use a HD Insight in a Hadoop cluster? I don't, those are the things you have to kind of stick to your gut, get as much information as you can, and make the call. As an architect, you're a leader, and you have to have the courage of your convictions, I would argue, to get it done. So that's that. As far as examples, one good one I have here is ThyssenKrupp Elevator. They are a Microsoft, it's a good case study actually. They are Microsoft services engagement. We're helping them with an IoT solution. Well, they want to do a few things. They want to do predictive maintenance on an elevator. When an elevator goes down, and if you're staying in the what's called Sky City Hotel, the elevators there have been pretty not so good. I thought I couldn't get in the first night I got there, so I had to step out and get another one. Just one of the elevators was down. These guys produce high-grade elevators for 100-story buildings, and they want to be the cost of maintenance. If an elevator is down in a skyscraper, it's a big issue. So they're putting sensors and devices on these elevators to capture all sorts of telemetry data to present back to the company how many floors they've gone, what parts do they have, and before understanding the wear and tear, the company can then send a technician, a field technician, and go out there and service the elevator before it ultimately breaks. And the great thing about that for these guys is they're now able to offer an SLA to the building managers, the real estate and facilities people. Say, we can guarantee a 99.9% uptime, and it's probably a great sales point, great advantage in selling that we have this uptime, because that's a really competitive thing compared to their industry. So it's a great competitive advantage there. So that's something that they're doing, and then they can charge that as a service. They can charge that SLA as a service, because if you're a building owner and you have hundreds of tenants, you want to charge a premium, obviously, for your rent, and obviously you can work out the economics. So it's vital, and it's proving out to be a really unique business model. That's ThyssenKrupp. This is also a really neat example. Called 88 Acres. This is what Microsoft is doing. This guy, Daryl Smith, he's the director of energy and sustainability for our real estate and facilities group. His charter is to help with optimization of Microsoft's buildings. Uniquely, everyone thinks of Microsoft as a software company, which clearly we are. But we also own, I think, 38 or 39 million square feet of real estate. That's a ton. We have offices which we own all over the Seattle area, the Redmond area. I trust some or many of you have been there. You've been to the Microsoft campus. We own all those buildings, lots of real estate. We have to manage the electricity bills, the heating bills, the lighting bills, all of those things. And there's just an enormous amount of waste that goes on there. So our electric bills, even living in Seattle, our utility bills, which is apparently one of the cheapest places just by virtue of the climate and the amount of power generation that goes out there. It's one of the cheapest places in America to run shop, to have a business. But we still have a huge bill as a company. And this guy has managed to save, I think, 30%. It's his investments and his expertise. He's created a playbook with his partners and to come in to understand. And they have a whole war room, if you will, and they know every building every sensor. They know what type of air conditioning it has, all the lighting, and they know if you're able to leave an office and there's nobody there, it auto dims the lights, auto turn off the lights. And they're really proactively doing a lot of work. There's actually a published case study. It's super interesting called 88 Acres. It's on the Microsoft website. It's really fascinating because this type of technology, and this is serving as a great case study, that other businesses are coming to Microsoft to say, hey, help me understand how you did this. What are the KPIs? How do you manage that? And how can I benefit from it? And I know here in New Zealand in particular, New Zealand is very focused on sustainability and energy conservation. So it's just something that might be important for your customers. Great case study that's out there. So as a summary here, just really quick, I hope I've been good at pointing out the following. I feel that architecture and architects are at the very, very center of IoT solutions. I don't think that they can take place without good, solid architecture. I would argue architecture is going to determine or define whether or not an IoT solution fails during a POC stage or succeeds. Everything is built on architecture. Okay? IoT, I would say, is advanced modern architecture, more so than anything else. It really, really requires the latest and greatest of these services that are, and these softwares that are out there. And in order to use them wisely and use them appropriately, you have to be really deeply versed. And I would say that was what I would call an advanced solution, advanced architecture, a modern architect. IoT projects are deeply complex. It takes a village to get this stuff done. From business to your partners to getting devices out there, sometimes it's really challenging. Teamwork is necessary. Oftentimes these projects are really, they're difficult and they're critical. They're mission critical. In some IoT solutions, it's actually a life or death type of thing. Very critical. And for me, I try to ingest as much information as I can, but I realize that the world is moving at such a rapid pace that I can't take it all in. So we can't learn everything, but we need breadth. You know, I might know a lot about telemetry ingestion, but I don't know much about machine learning. And machine learning folks, you probably need the role of a data scientist to deliver that type of solution. And data scientists are pretty hard to find, but at least you need to know what they are and what's their methodology, how do they go about their work, and are you, as an architect, are you giving them the right data from your devices, if you will, in order for them to do the type of experiments that are required to yield the right results. So again, you can't learn everything, but you need breadth. And I would say don't be afraid, get started and continue to learn. It's a vibrant technology. It's coming up. It's continuing, and I do think that it's going to present a great opportunity. And the more we learn about it, I think the more opportunities it will afford for us individually and reward us with great work and cool projects moving forward. And I think that's my session. So thank you all for your time, and thanks for coming.